This is a continuation of section 3.1, which is on the derivative of a function. We're going to kind of look at things from a graphical perspective now. So what we're going to focus on is graphing f prime from the graph of f. So again, we need to keep in the back of our heads that f prime is essentially the derivative of the function if it represents the slope at a particular point. So I'm going to start with something that we all know. Okay? I'm going to start by graphing the function f of x equals 4. Just a horizontal line. Okay? F of x equals 4. And now what I'm going to do is I'm going to graph the derivatives. So on the right-hand side, I'm going to be graphing the derivatives. Okay. Now I know that this slope, this line slope is 0. Okay. So when I go to graph f prime of x, everywhere along that line, the slope is 0. So when I go to graph that line, it's going to be kind of hard to see. I'm going to make it kind of dark here. Okay. Everywhere along that line, okay, the slope is going to be 0. So essentially, if I was to put a point, like let's say at 2, okay, at the point 2, okay, same thing over here. When you graph the derivative, you want to essentially read what the derivative is right off the graph. So at f prime of 2, my y value is 0. So f prime of 2 would be 0. And that is also true on my original graph. The slope is 0. So at the point x equals 2, the slope is 0. Let's look at another example. Okay, and again, I'm just sketching here. Let's say that I have g of x equal to 2x plus 3. Now again, that derivative represents slope. So everywhere along this line, the slope is always going to be 2. So when I go to graph that derivative, it's going to look like a horizontal line, okay? And it's going to be at the y value of 2. So if I put a little 2 there, everyone can see that's kind of my y value, so I know that g prime of x is 2. So again, if I was to pick a point somewhere on that line, okay, if I was to pick, I don't know what, here, the x value of 3, I know that the slope is 2. So if I go over here to this graph, my x value is 3. I'm reading it right off the graph. I'm going to go up to 2. So that would imply that g prime of 3 is 2. So again, we're representing slope. Now let's say if we have a piecewise function. Okay, again, I'm just sort of approximating my graphs here. We have a piecewise function that looks kind of like this. So if I know that h of x is 3x plus 4 on this side, and I know on this side this line is represented by k of x equal to negative 2x plus 9. So again, let's think about graphing the derivatives over here. The slope of my first function, and these lines intersect at 1, the slope of my first function is 3, so I'm going to have a straight line at 3. Then I'm going to stop at 1 because the slope of my next function is negative 2, so I need to go into the negatives. So this is going to be 3 up here, and this is going to be a mark at negative 2. And it continues on infinitely in both directions. Okay. Important here is you need to have open circles. Okay. Because at 1, that derivative is not defined at 1. The slope from the left coming in is 3. The slope from the right is 2. So we cannot balance a tangent line on that point of 1. So we have to say at 1 that there is no derivative. So here I would say f prime of 1 is dne. So I can't have a point there to read off of it. However, if I wanted to say what f prime of 4 was, f prime of 4 is going to be 2. f prime of 4, if I go to 4, and I'm just going to go down to, negative 2, I'm going to go down to negative 2. What about if I want to know f prime of negative 5? Negative 5, I'm going to go over here on my graph, negative 5, and I'm going to go up to 3. So I know that my slope is 3 at those points. Now we can get into curves, which is kind of where it gets very interesting. So we can get into curves here. So let's say I want to look at the parabola of y equals x squared. So the function of y equals x squared. I'm going to call it p of x equals x squared. Now, when you graph these derivatives, I will tell you the easiest points to graph are the ones that are the zeros. That kind of gives you an idea. So at x equals 0 here, I know my slope is 0. So at x equals 0, I'm going to put a point at 0. I know my slope is 0. So I'm going to say that, p prime of 0 is 0. Now I kind of have to pick another graph, another point on the graph, because I really want to approximate those tangent lines. And here's where it gets really tricky. It really is just an approximation. So I'm going to look at the point of 1 and negative 1, because what you want to do when it's a curved graph is you want to kind of look for some symmetry here. Okay? And then what you want to do is you want to draw in a tangent line at 1. So you want to look at what's going on, a mini tangent line at 1. So you want to look at what's happening there at 1 and what the approximate slope of that could be. Okay? Now I know at 1 it goes through the point 1 comma 1. Okay? And I know my parabola, okay, at 2, which might be up here, goes through the point 2 comma 4. Okay? So I kind of want to approximate what's going on here. I'm not 100% sure, okay? But I'm thinking here I could probably approximate this slope of this line to be maybe up 1 here and then maybe over a half based on what I have. So maybe up 1 and over a half. So I think my slope would be 2. So then at the point 1, I'm going to have a slope here of 2. And again, you're drawing in mini tangent lines and just approximating them. So, and then I know I've got a symmetry over here at negative 1. So I've got my mini tangent line here. I've got a slope here at negative 1. So at negative 1, I know my slope is negative 2 because it's going down, so negative 2. So I'm going to point a point there. And then what I'm going to do is I'm going to draw in my line. And it would be a little easier to see on graph paper. So therefore I know that p prime of 1 is 2 and p prime of negative 1 is negative 2. And here's where you kind of have to really begin to see the patterns of what's going on. A parabolic shape, okay, here is going to give us a line over here. Okay? The other thing to start to look for, which comes into play here, is this slope on my original function is negative. Okay, so it's falling. If you read all of the slopes over here, like at negative a half, the slope is negative. Okay, it might be negative 1 here. At negative 2, the slope is also negative. So that's telling me about my original function that it's decreasing. And the same thing over on the right-hand side. This function is increasing over here. So the function's increasing. Over here, my slopes are all positive. So if I was to read off the line, you know, the slope at 1. Okay, the slope at 1 we know is true. The slope at a half, we might want to read off here. It might be 1. And that would make sense based on the slope of the parabola as well, that as we move up the parabola, our slopes are getting steeper. So at 3, our slope might be 6. Okay? So again, we're reading it right off those y values. This is sometimes the hard part to interpret, that you're reading it right off the y values. So now let's look at a cubic example, because very often you might not be given the equation to kind of look at. So let's look at a cubic example here. So if we look at a cubic example, I'm just going to say that the maxes and mins are at -2 and 2 just to make our lives a little bit easier here. And I'm going to go through 0. Okay. And then I want to graph, if this is my function m of x, I want to graph m prime of x. Now I'm thinking in my head it's probably going to be a quadratic, but I'm not 100% sure. So let's kind of look at the patterns for what we see. I'm going to put 2 and -2 on my graph because those are where I have my horizontal tangents, at 2 and -2. Those are where I have my horizontal tangents, so I'm going to call those points 0. Those slopes are 0. Okay? So I know that m prime of 2 is 0 and m prime of -2 is also 0. And now here's where I really have to kind of guess in terms of what's going on. And again, I'm going to look at symmetry. And I'm going to draw in little tangent lines. So if I look here, I'm thinking this tangent line is pretty steep if it touches at a point there. And I'm going to say, I don't know, maybe I go up 2 units and maybe over a half a unit. So I go up 2 and maybe over a half. So maybe that slope there at 3, right? Maybe we can call that 3. At 3, maybe my slope is something like 4. Okay, so maybe this is 4. Bring it down a little bit there, sorry. So maybe my slope is 4. And again, that's a positive slope there. Now again, I'm going to come back over here and kind of look at the same idea here. And it looks like that's pretty similar, maybe a little bit less steep than 4. So at 0, maybe I'll call my slope, I don't know, maybe -3.5 or something. We'll put it here at -3.5, and I'm going to read right off of that. So we said that m prime of 3 was 4, and I'm going to call m prime of 0 to be -3.5. And then it looks like this slope over here is about the same as this guy over here. So I'm going to call my slope at -3 also 4. So m prime of -3 is also 4. Again, looking at that symmetry is really important. And now what I can kind of do, I've got a smooth curve on the left, so I'm going to have a smooth curve on the right. And then in fact, I think I have my parabolic shape, which I was predicting. And again, it's important to analyze what's going on here. Okay, so m prime of x is going to be a quadratic. And it's important to notice here, in this part of the function, up until my max, the function is increasing. While here, I have all positive numbers for my slope, so when I read -2.5, I'm getting a positive answer. It's going to be a little bit less than 4, which would make sense because my curve needs to flatten out. Those tangent lines are flattening out because eventually they're going to hit 0. Now here, my function is decreasing. So my function is decreasing. All my slopes are negative. So down here, all my slopes have negative y values. The function may be increasing or decreasing, but the slopes are negative. So at -1, my slope should be a little bit less steep than it would be at 0 because it's going into that point there. So at -1, I see that my slope is going to be a little bit less steep than at 0, which is -3.5. Same idea, once I hit my min, all of these slopes are positive. Starting at 2, all of these slopes are positive. They're getting steeper and steeper. So at 4, I'm moving all the way up here, and I'm going to get steeper and steeper. And again, the biggest thing with graphing f prime from f is that you really want to be able to analyze the graph and not necessarily get so many minute points on each part about the slope, but really sort of being able to analyze the graph and figure out when is the function increasing and what that does for the derivative, because that's going to come into play quite a bit later on.